Welcome to Mechanical Tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about PCB U-shape enclosure design with a top-down approach. So this is the enclosure I am going to create. So this is the PCB. So I am going to create bottom cover or bottom casing for placing the PCB board and top cover. So I am going to show you how to create both the components. See, this is the exploded view. And also I am going to show you how to create this forming tool. This is the bridge lance. For placing the PCB. Let's start now. So initially I am going to create the bottom casing or bottom cover. So we have to take new assembly file. So I have already taken a new blank assembly file. Now we have to place the PCB board. So in top-down approach, initial component should be constrained with planes. It is the best practice. Top with the top plane, right with the right plane. See, this component is constrained now. Now we have to take a new part file. So I have already created a blank file, so I am opening that. So select the top plane, create a sketch. So this is the rectangle 280 by 200. Select the base flange. So it should be downwards, because since we have selected the top plane, should be downwards. And sheet thickness I have taken 2 mm and K factor is 0.45. So it should be downward, because we are going to calculate this bridge length height. So this is the bridge length. PCB is going to place on this bridge length feature. Now select edge flange. Select these two edges. Height is 100. And we have to select material inside to maintain the overall length. So here I am going to show you. See, we have to select this. This left side edge should match exactly this base flange edge. See, here we have to constrain the sketch. And this height should be always from the bottom edge. We should not select the top edge. So similarly we have to constrain the other sketch. At this moment I am not constraining. Now we have to create the side flanges. See, the side flanges. So select the edge flange. And select the all three edges. This is 10 mm. And we have to select the material inside to maintain the overall distance. See here, we can see from the top view. See, this outer edge of the edge flange should match this edge of the other flange. Similarly, we have to select all the three edges. See here, whenever we create edges side by side, there will be a side projection, this projection. So we should not use cut feature to remove this. What we have to do is to remove this additional material. So we have to select trim side bends. So when we select this option, so it automatically removes the additional material. So when we see the flat pattern, see there is a sharp cutout. Now I am going to create this top ear flanges. So select edge flange and select this edge and place it over here. Say OK. Now edit this sketch, keep it normal. Now you can make construction line and select a 3-point arc. Make this tangent. Select these two entities, arc and line, make it tangent. And similarly the other side, make tangent. Now see, in top down approach, try to dimension from the origin instead of edges, because we frequently change the dimensions and the design. So we have to always try to dimension from the origin. So we have to constrain with 3 dimensions. One is 80 and the width of the flange is 30 and the center point from the origin is 25, and say OK. See here. See, for this flange we have to select material inside. Now we have to mirror this feature. So instead of creating new feature, we can mirror directly. So go to mirror command and select right plane and this feature. Now for creating other side, once again we have to mirror. Here we have to select front plane and this edge flange and mirror feature. Now we have to create holes. So go to sheet metal, select a simple hole feature. say OK. Now edit the sketch, keep it normal, select this point, move near to this edge and place it over here. We have to move near to this edge and place a circle. Now select all 4 circles, make it equal. Now it is constrained. Now say OK. Now I am going to create rear side cutouts. So select this face, go to sketch, keep it normal. So I am going to draw a slot sketch. Now this we have to give the dimensions. Now we have to pattern this slot. Flip the direction. Distance is 15 and 10 slots. Say OK. So select cut extrude. So in sheet metal we have to always link to thickness. Say OK. Now this feature is created now. Now I am going to create this vent feature. So select this face, go to sketch, keep it normal. Draw circle. See, we have to provide distance from the origin. So it is 50 by 50. $65. So I have drawn 4 circles of 65, 45, 26 and 15. So make it coincide. Now we have to trim inside lines. So we have created a ribs with for 84 degrees angle. Now I am going to use vent feature. Go to sheet metal and select the vent. Here we have to select the outer boundary circle. Outer circle. Now select this rib. So we can change the size according to our requirement. Here I am keeping 3 mm. So here we can provide the radius. See, this vent feature is created now. Next I am going to create the cutout for this power connector. So we have to assemble this connector in the main assembly. So let's go to assembly. We have to assemble this bottom casing. Select front plane and front plane. Give the meeting conditions. Top plane with top plane. See here. And we see the cross section. See this. PCB is exactly assembled at the base. So what we have to do is we have to increase the height of the PCB cover. So instead of coincidence, we have to provide 10 mm. So it is in reverse direction. Flip the direction. Now let's check the cross section. See, it is floating. So now we have to assemble the power connector. insert this component in the assembly file, and now we have to constrain. Select this face, and this top face of the bottom enclosure. Let's move near to the right side flange. So we have to give the meeting conditions. Select this edge and this face. Distance of 50. This bottom and this edge. So we have to provide the offset distance of 50. Flip the direction. Say OK. So usually plastic components will have a draft angle. So that's why I have selected the edges. If it is simply flat face, we can select the face and give the meeting condition, but usually the plastic components will have the draft angle. Now I am going to create a cutout on this flange. Select this face, go to sketch, keep it normal, take simple circle. This is just for reference. Go to sheet metal, extruded cut, link to thickness, and say OK. See, this cutout is created. Now we have to go to assembly mode. Select this component and go to edit component. Now select this sketch and edit. Here we have to select the top face. See this top. So since it is in edit mode, it won't select easily. It converts to transparent. See, all other components converts to transparent. So what we have to do is right click and select other. Here We can see this face is highlighted. Select this and simply go to convert entity. So it is converted. Delete this circle and keep it in front view. See, we have to make sure that sketch is closed completely. Say OK. Come out of the edit mode. Now open this bottom cover. See, the cutout is created now. But we cannot give exact dimension because there is a possibility of fitment error during assembly. So what we have to do is we have to provide some clearance. Select all these sketches, make construction, say OK. Now select the sketch once again, make offset, give some value, for example 0.5 mm, and say OK. Now let's check in the assembly. See, there is a clearance. So you can see the clearance at this location. Now we have to provide a slot for this cable. So open this file. So it is in the rear side. Select this face, go to sketch, keep it normal. Make some rectangle. Make this construction. Take 3-point arc. So we have to make coincide. Merge it. Select this point. It is not taking tangency, so select these two entities. So it should be tangent. So distance between this line and edge is 10 mm. We can give any value. So 93 from the origin and 30 height from the origin, and slot dimensions are 10 and 22. So say OK. See, the sketch is created. Now we have to go to sheet metal and extruded cut. Link to thickness and say OK. See, here we can't link to thickness because we have to remove this material. So we have to edit this and remove link to thickness. Let's say 20 mm. See here. So we can edit this slot in the assembly mode also. Suppose if you want to modify this slot dimension, so we can straight away edit this sketch in the assembly itself. See here. We can see the wire is a little bit intersecting with this flange. So we have to reduce the height of this cutout. So let us give 25 mm. And say OK. So that's how we verify in top-down approach. So there is no interference now. Next I am going to show how to create this bridge lens for mounting the PCB. So I am going to create this bridge lens with forming tool. So I have taken a new SolidWorks part file to create the bridge lens forming tool. So select the top plane, go to sketch and create a simple square. So make these two lines equal. So it's 50 mm. Select this sketch and select extruded boss. So here flip the direction. You can give any value. I am taking 5 mm. Now select the front plane, go to sketch, keep it normal, keep it in wireframe. Select this edge and convert entity. Now trim these two lines. See here, select this line, select midpoint and select control button and select origin, make it vertical. So it should be symmetric. So select this line and this line, make it equal. So it becomes symmetrical. Now we can assign dimensions. So the dimensions are 20, 10 and 50. So the angle is 50. So select this extruded boss. Make it mid plane and depth is of 15 mm. Say OK. Now we have to apply fillets. So whenever we design any forming tool, we have to keep in mind the sheet thickness. See, the fillets should be always more than the sheet thickness. So here I have taken 2 mm of sheet thickness. So this fillet is 3 and bottom side is 4 mm. So these two are more than the sheet thickness. If fillet radius is less than the sheet thickness, then the forming tool will fail while placing in the component. So now we have to remove this material. Select this face, go to sketch, convert entity, select extruded cut, through all and say OK. Now this feature is ready. We have to apply the forming tool feature. So select stopping face, and faces to remove we have to select these two sides, and the rest of the faces will be the forming faces. Say OK. So after that we have to save this file in the forming tool folder. So you can right click and open this folder and we can save it. Now open this bottom cover. I have already saved this forming tool in this folder. Select this and flip direction. See, it is in, should be in top direction. Say OK. So we don't know the location of this forming tool. So what we have to do is, in top down approach we have to go to assembly. Select this and select edit component. Select the bridge lines feature. Go to position. See, this is should be at a center of this hole. So what we have to do is, we have to move near to this and place it over here. So automatically it moves. Now other locations, simply select this point. We have to move near to this circle and place it here. So automatically it places. So I've placed at 4 locations. Come out of the edit mode. See, we can see 4 bridge lines features. So I will open the component. See here. Now we have to create a hole on this face. Select this face, go to sheet metal module, select simple hole. Say OK. See, as per design, we have provided this height of 10 mm. See here, this is 10 mm. So PCB also we have assembled at 10 mm height from this base. So there won't be any interference. Now we have to go to assembly. Now edit this hole. Keep it normal. Either we can delete or modify the dimension. So I am deleting this. Go to convert entity. Here select other. So we can see this edge. Similarly, we have to select this edge and convert entity. Right click, select other, select this edge, convert entity. We can give clearance also. We can, instead of convert entity, we can give offset entity. Come out of the sketch. Now come out of the edit mode. Now we will open this file. Exact holes are created now. See here, this edge is not selected. Edit the sketch. Go to convert entity. Select other and select this edge. Say OK. See, this hole is created now. Keep it in isometric. Now the complete bottom case is created. Now I am going to create the top cover. So we have to open a new SolidWorks part file. Select the top plane, go to sketch, create center point rectangle, go to feature, go to sheet metal module, select base flange. We have to take 2 mm and K factor is 0.45. Say OK. Now we have to assemble this component in the assembly file. Select the top cover, say OK. Select the bottom face, and this top face, say OK. Now select this front plane and this front plane, assembly front plane and component front plane. Make it coincide. Right side and right side plane. Make it coincide. Now we have to select this file and select the edit mode. Now we have to modify the sketch of the base flange. See, this outer edge and this line should be collinear. Say OK. And this edge and this line should be collinear. So we can see exactly matching. Now we have to add the side edge flanges. So select this edge flange, this edge flange. So height we are going to modify in the assembly. So before that, what we have to do is we have to constrain the sketches. So show the sketch, So we have to edit the sketch and select the sketch and this line and this line. Select this both the lines, make it collinear. So if I modify one of the sketch, automatically updates to the other sketch. Say OK. So I am going to explain why I have done this in assembly. See, there is a mismatch with the height. So what we have to do is select this first sketch, select this edge, this bottom edge, and this line we have to make collinear. Say OK. Come out of the edit mode. See, this height is matching exactly, so we can hide this sketch. See here. Now there is a interference. So to avoid this interference, we have to edit this flange. We have to select bend outside. See here, I will show in front view. See, if it is bend inside it, it will match exactly the outer one. But when we select this, the inner edge will match. So there won't be interference. And if you want to give some clearance, we have to give offset, and here we can provide 0.1 mm and say OK. Now we can see there is no interference. We have some clearance. So it is easy to assemble. Now for better fitment, we have to add jog feature. So select this face, go to sketch, keep it normal, draw a line joining the two edges. So we have to make sure it is horizontal or not. Select this edge and a line. $20 mm. Now go to sheet metal module, select the jog feature. Keep it in front view. See here, we have to select the fixed face. So select this one. Now we have to see it is moving outward or inside. So it has to move inside. So flip the direction. See here. And we have to select bend at center line. And this one, depth should be more than the sheet thickness. So sheet thickness is 2 mm. I have given 2.5. Say OK. Similarly, we have to create other side. So select the face, go to sketch, say 20 mm. So we have to create jog once again. You put in front view. So we have to select the fixed face, front view. We have to flip the direction. So since this top cover is in U shape, there is a possibility of expanding of these flanges. That's why to have a tight fitment, we provide this jog feature. So let's go to assembly. See, there is an interference. So during assembly, we can expand little bit and we can push inside to have close fitment. Now we have to create the side slots. So let's open the part file. Keep it in isometric. Select this face. Go to sketch. Keep it normal. Draw a straight slot. Select this and make it. Select this point and this point. Make it vertical. So slot dimensions are 6 mm, 45 and 40 from the origin. Now I am going to create a linear pattern. Select this sketch. Select linear pattern. Here I'm going to take 15 and 5. Once again I am going to select this sketch, linear pattern. Now I am going to flip the other direction and 5. This is 15. Go to sheet metal, select extruded, cut and select the sketch. Here we can give through all. See, it is created both sides. Now we have to create the top holes. So simply select this face, go to sketch, select simple hole and say OK. So here I am going to modify in the assembly. So go to top cover, hole feature, edit sketch. Keep it in wireframe. See here we have to select this edge and convert entity. Delete this circle. Here we have to select this edge, convert entity, convert entity, convert entity. Come out of the assembly mode, edit mode, see here. See here we have to create hole on this bottom face. We forgot bottom cover, so we have to create a hole. So open this file. Select this face, go to simple hole, say OK. Go to assembly file. So here we have to edit this hole. Go to edit sketch. Here we have to select this edge. Select other and select this edge and convert entity. Similarly, select other, select this edge, convert entity. Delete this old sketch and come out of this sketch. Come out of the edit mode. Now let's see in the component. See here, two holes are created. Now complete assembly is done. See here. This is the bottom casing. This is the top cover. I'll show with PCB also. See here, it is mounted on the bridge lens. We can customize as per our requirement, height and see here. This is for ventilation. This is for cable. And these top ear flanges are for mounting the top cover. So the complete assembly is created. Now we have to assemble the screws. So I'm using pan head screw. I have to change the orientation. Go to mate. Make it concentric. Select this face. And this bottom face. So since it cylindrical, two mating conditions are sufficient. Now select this pan head screw, right click, copy mates. We can repeat this and concentrate. See here, uncheck this, repeat mates, and we can select this flat surface and this concentric. Select this concentric and this flat surface. So same screws I am using for PCB mounting. So right click, copy mates, so we have to follow the same process, concentric and coincidence. Concentric and mate, coincidence. Now unhide this top cover. We'll make it transparent. Now we can see the complete assembly. So inside screw fasteners, bridge lens feature, see these usually will be self-threaded screws. So ear flange, so in upcoming video I'm going to add the drawings of the bottom and top cover. So this is how we create U-shape enclosure with top-down approach. Thanks for watching.